For this video, we're going to talk about simplifying radicals. We've done this in class already, but now we're going to go a little bit more in depth. So, first let's look at the parts of a radical. Our index is a little number in our little v. Normally we see the square root, and so we have a 2 there, but we don't have to write it. It's kind of like a little invisible 2. Then the radical is the actual shape, and underneath the radical is called our radicand. So, simplifying square roots. We used this a lot when we were doing our quadratic formula. I lost my pen. Oh, there it is. Okay, so if we're going to simplify 24, we're going to do our factor tree. So 24 becomes 2 and 12, 12 becomes 2 and 6, 6 becomes 2 and 3, and then this is our prime factorization. So we can rewrite the square root of 24 as 2 times 2 times 2 times 3. Alright, now that since we have a square root, it's like a little 2 is supposed to be here, we're looking for groups of 2. So we have one group of 2 2's. So for every group, we bring 1 out. So for that group of 2, we're going to bring 1 2 to the outside. Under our radical, we have 2 times 3. We can simplify that to 2 times the square root of 6. Alright, square root of 512, we're going to do the same thing. We're going to do our factorization of 512. So in 512 we have 2 and 256. 256 becomes 2 and 128. 128 becomes 2 and 64. 64 becomes 2 and 32. 32 is 2 and 16. 16 is 2 and 8. 8 is 2 and 4. And 4 is 2 and 2. Remember, your factorization can go different ways. So up here at 64, I could have said 8 and 8 and broke it down differently. Alright, so the square root of 512, we can rewrite it as the square root of all these 2's. So we have 2 times 2 times 2 times 2 times 2, 2, 2, 2, 2. 9 2's. Alright, we have the square root, so we're looking for groups of 2. So there's a group, there's a group, there's a group, and there's a group. So for every group, we're going to pull out 1. So we have 4 groups of 2, so we pull out 4 2's on the outside. And we have 1 left under the radical. Then we simplify. 2 times 2 times 2 times 2 is 16. And we can't simplify under the radical, so our final answer is 16 root 2. So now we're going to throw in some variables. Anytime we're going to simplify radicals with variables, it's going to be the same steps, just instead of having only numbers, we're going to add our variables. So 98, if we do our factorization, it becomes 2 times 49, and 49 becomes 7 times 7. So if we start rewriting our radical, we have 2 times 7 times 7, and then we have k squared, which is just k times k. We're looking for groups of 2, so we have 2 7's and 2 k's. So for every group, we pull 1 out. So we have 7 times k, under our radical is a 2, and we can't simplify that anymore. So our answer is 7k times the square root of 2. The square root of 32 x cubed y squared. We're going to start with 32. That becomes 2 and 16, 2 and 8, 2 and 4, 2 and 2. So if we rewrite the square root of 32, we have 2 times 2 times 2 times 2 times 2. We have x cubed, which is 3 x's, and y squared, so 2 y's. We're looking for groups of 2. So we have 2 groups of 2's, 1 group of x's, and 1 group of y's. For every group, we pull 1 out. So we have 2 times x times y. Under our radical, we have 1 2 and 1 x. Then we simplify. 2 times 2 is 4. We can't simplify anything else, so we end up with 4x squared times the square root of 2x. Now you try. Alright, so if you want to, you can pause the video now and work this out on your own and see if you get the same answer that I do. Or if you're still stuck, you can walk through it with me. So the square root of 180, x to the fourth, y, z to the fifth. We'll start with 180. 180 becomes 2 and 90. 90 becomes 2 and 45. 45 becomes 5 and 9. And 9 becomes 3 and 3. Terrible 9. So if we rewrite our radical, we end up with the square root of 2 times 2 times 3 times 3 times 5. And we have 4 x's, 1 y, and 5 z's. We're looking for groups of 2. We have a group of 2's, a group of 3's, 2 groups of x's, 2 groups of z's. So we rewrite it. For every group we pull 1 out. So we have a 2 times 3 times x times z times z. Under our radical we have a 5, a y, and a z. Now we simplify. 2 times 3 is 6. X times x is x squared. Z times z is z squared. We can't simplify anything under our radical, so we just have 5yz. So 6x squared z squared times the square root of 5yz. So we have more than just square roots. We also have cube roots, fourth roots, and we have all different kind of numbers. Sometimes we say the nth root. That n can be any number. So if we look at the cube root of 24, we're going to start out the same way we do with square roots. So we have 2 times 12. 12 becomes 2 times 6. 6 becomes 2 times 3. So we end up with the cube root of 2 times 2 times 2 times 3. And now instead of looking for groups of 2, we're going to be looking for groups of 3 because it's a cube root. So we have one group of 2's. So for every group we pull 1 out. So we're left with 2 times the cube root of 3. And we can't simplify that anymore, so that is our answer. Now we have the fifth root of 224. So we'll start with our factor tree. And 224 is 2 times 112. 112 is 2 times 56. 56 is 2 times 28. 28 is 2 times 14. And 14 is 2 times 7. So we end up with the fifth root of 2 times 2 times 2 times 2 times 2 times 7. 5 2's. Now because of this 5, we're looking for groups of 5. So we have 5 2's. For every group we pull 1 out. So we have 2 times the fifth root of 7. Alright, we're going to do the same thing now, but we're going to throw in our variables. So if we look at the fourth root of 128 x to the 7th, y to the 7th. Oops, lost my marker. Alright, we look at 128. That becomes 2 and 64. 64 is 2 and 32. 32 is 2 and 16. 16 is 2 and 8. 8 is 2 and 4. 4 is 2 and 2. So we can rewrite this as a fourth root of 2 times 2 times 2 times 2 times 2 times 2 times 2. 7 2's. And then we have to throw in our variables. We have 7 x's, 2, 3, 4, 5, 6, 7, and 7 y's. 1, 2, 3, 4, 5, 6, 7. So now we're looking for groups of 4 because it's a fourth root. So you have one group of 2's, one group of x's, and one group of y's. So for every group we pull 1 out. So we pull out a 2, an x, and a y. And we're left with the fourth root. Under here we have 3 2's, 3 x's, and 3 y's. Then we simplify. So we end up with 2xy times the fourth root 2 times 2 times 2 is 8. Then we have x cubed, y cubed. So our final answer is 2xy times the fourth root of 8x cubed, y cubed. Now look at the cube root of 56x to the fifth y. We'll start with our 56. That becomes 2 and 28. Terrible 2. 28 becomes 2 and 14. 14 becomes 2 and 7. So if we rewrite it, we have the cube root of 2 times 2 times 2 times 7. And then we add in our variables. We have 5 x's and 1 y. We have a cube root, so we're looking for groups of 3. We have a group of 2's, group of x's. For every group, we pull 1 out. So we have 2 times x. Under our radical, we have a 7, 2 x's, and a y. Then we just simplify. So we end up with 2x times the cube root of 7x squared, y. So again, now's your chance to try. If you think you've got it, go ahead and pause the video and do it on your own and double check with me. If you're still stuck, you can go ahead and work it out with me. So we got the sixth root of 448, x to the seventh, y to the seventh. So we'll start with 448. It gives us 2 times 224. 224 becomes 2 and 112. 112 becomes 2 and 56. 56 becomes 2 and 28. 28 is 2 and 14. And 14 is 2 and 7. So if we rewrite it, we have the sixth root of 2 times 2 times 2 times 2 times 2, 2, 2, 7 2's, 6 2's. That last one shouldn't be there. Alright, then we have 7 x's and 7 y's. Alright, so we're looking for groups of 6. This is the sixth root. So we have 6 2's, we have 6 x's, and we have 6 y's. So for every group we pull 1 out. So we have 2 times x times y times the sixth root, and the only thing left under our radical is x and y. We can't simplify that anymore, so our final answer is 2xy times the sixth root of xy.